Okay. So any doubt on this ready valid handshake, how the ready valid handshake is happening?
No, sir.
Anyone, just please ask because we have very less time.
No, sir.
Okay.
The valid and ready and associated at same time. Then.
No issue. That it will for one clock it should be high. If both are resetting at the same time at the next clock edge, it will sample the data. Basic. Clear enough? Now we'll go back to the other signals we
Yes, sir.
have. Yes.
If what will happen if valid goes down before the ready signal? Will it misbehave or some error or something? What will happen?
That will be like no, like the it will be handled by the interconnect basically, but the interconnect can provide a error to it, but it's according to the specification, it's not a valid condition, not a valid scenario.
So will the state that we have different state in AX side, idle state and start, or the I think three states are there. So what will happen to those states?
No,
Will it
basically
go back
those
to the idle
states,
state or?
the states basically are in the APV protocol. So in AXI, there is no such concept of the state. So
Okay,
it will go back, but on like the bus will be in the idle by default. So it can have the whenever the valid is zero, so the other signals can have any possible values. So the slave doesn't sample them, or it doesn't take care about the other signals. So
okay.
valid means a valid information.
And one more question: does
Hmm.
the read channel also have a response?
Yes, the read channel, on the read data channel, we have the response signal. Like over here, if we see the read data channel, we have ID, we have data, response, last user, and ready valid.
Okay, sir. Okay,
So along with the data, the response will come.
okay, sir.
So ID is basically we are giving a tag to a particular transaction. So whenever a new address will be generated, so we are providing a ID to that particular address, and with the same address, with the same ID only, we have the WID as well and a BID in the that same ID will correspond to the write data and the response. So if a address is generated with the ID 0 or ID 1, so the data will also come with the same ID on the write data channel, and for the same ID, the response will come on the BID. So that's how we are just like linking all the three channels. like for like जिसके लिए हमारा address generate हुआ है, how the data is corresponding to that address and how the right response is corresponding to that particular address. So that we are linking with the help of ID signal.
ID, unique ID or
It can be a unique ID or it can generate the same ID for all the different addresses. So there might be a possibility the master supports the width of the ID is quite small. So there might be chances the first ID has not completed and it has generated a new transaction with the same ID. So in that case, if the IDs are same and the transaction has not completed, then the data channel and the response channel will generate the data and the response in the same order. Okay, the order cannot be changed, but in case the IDs are different, then the order can change on the data channel and the response channel. Okay. Now address is like basically we are just providing the address. Length will tell us about the how many beats are there in a transaction. So it will tell us about the burst length. So basically what's the difference between burst and a beat is a complete transaction. I have this table here saved. So over here, if you see, I have taken few signals, the major signal, clock, valid, ID, address, burst, size, length, data, strobe, all the major signals we have taken. So over here, I have generated a transaction with the ID 1. My address is 04. Okay. And what is a difference between beat and a burst? Now I have taken the length as 3. So by default, whatever the value we are passing in the length plus 1, that number of beats will be transferred on the data channel. So every time if we are providing 3, if we are providing 5 plus 1, that much amount of beats we have to transfer on the data channel. Okay, so beats basically is how many number of data beats are transferring in a single burst. So this I have provided the length as 3, so that means 4 beats like D1, D2, D3 and D4. These are the number of beats, and this complete collectively we call it as a burst. Okay, so the length is basically your the number of beats in a burst, and size corresponds to the number of bytes being transferred in a single beat. Okay, so size the width of size is 2 down to 0. So we'll calculate the size as 2 to the power n. So I'll show you. This is the table. Like if the size value is 0, the number of byte transfer is 1. 1 for 2 to 4, like 2 to the power n number of bytes we are transferring in a particular beat. So maximum 128 bytes we can transfer in a single beat of burst. Any doubt in the what is length, what is size, and what is AWID?
Hi, Tushar.
Also.
So,
Hmm. Hi.
in AXI, we have a 4 KB boundary, right? So, is it
Yes.
related to length and size of the address?
Yes.
AWAR
So
size and
there, let's say if we have a large size of let's say we are sending 64 bytes, and my length has also become like 256, so it will be might be 12k or 16k of data, kb of data. So
Mhm,
that means in a single bus we are crossing the 4k boundary,
mhm.
so that should not be the case.
Okay.
Hmm.
So, why it is only 4 KB is permissible? Why not 8 KB or 16 KB?
See, in AHB we have a 1K boundary, and in AXI we have 4K boundary. It all depends upon the frequency and the type of memory we are accessing.
Okay.
Hmm.
So, if type of memory is changed, then this boundary
नहीं
will change
नहीं
or
नहीं,
not?
ये बाउंड्री कभी भी चेंज नहीं होगी. हमारा बाउंड्री इस AXI में हमारा फिक्स है. इट विल बी 4 KB ओनली.
Mm-hmm. For one transaction, for one bus transaction.
फॉर
Okay.
वन बस ट्रांजेक्शन.
Mhm.
जैसे इसमें आईडी आपने वन दिया है AWS, वो एड्रेस के लिए या बर्स्ट की आईडी है जो कंप्लीट डेटा है?
लाइक इट्स द सेम थिंग ना. Burst is like जो आपका एक एड्रेस, like for a single bus we are sending only the starting address. So हम इस एड्रेस के कॉरेस्पॉन्डिंग हमारी आईडी 1 है. So ये हमारा एक बर्स्ट ट्रांजेक्शन स्टार्ट हो गया है.
ये तो स्टार्टिंग एड्रेस
स्टार्टिंग एड्रेस है ओनली. In AXA we send only the starting address. The corresponding addresses that slave itself has to calculate it based upon the size. It will just increment the address and store it to the next data location. Hmm. ठीक है. So
आईडी की लेंथ तो वो वेंडर ही डिसाइड करता है.
it depends upon the specific IP or NOC. So like over here, if we see, like there are three types of transaction, 1, 2, and 3. So we can get the like the data and the response in any kind of order. Like firstly, the first data is complete, second and third. But now this one more thing, like this WID field is present only in AXI3. This is not present in AXI4. नहीं शुभम नहीं है शुभम गोयल. He is joined online. Online. Hmm. Okay, so WID is not here. So in AXI4, it is necessary the whatever the transactions being generated on the address address channel, the data should be driven in the same order the address has been generated, because the WID field is not here. So it cannot the write data interleaving, or it cannot change the order of the data. But the response order can change because we have a BID field in response channel. Okay. इस पे कोई डाउट है आपको? नागेंद्र सर, आपको भी? नो डाउट. Now we see about the different type of burst. So basically we have three different type of burst. One is a fixed burst, wrap burst, and the INCR burst. Fixed, INCR, and the wrap burst. So the fixed burst, I'll take the example only. If my fixed burst is there, let's say I have generated the address 04 on a fixed burst, size is 2, and my length is 4 beats. So how the fixed burst will work? It will store all the data beat at the same address location. So for all the data beat, my address will be the same. So what is the benefit of having such kind of burst? Yeah. So if we want to fill or like pop the data from a FIFO, in that case we can use the FIFO. Like we can use the fixed burst. Okay, so we are just targeting to the address, starting address, base address of the FIFO, and it will just keep pushing the data into that FIFO. Okay, and in case of INCR burst, let's say this is an example for INCR, we have taken an address 10. So INCR is simply, it will keep incrementing the address based upon the size and the length. Now my size is 4 byte and length is 4 beat. So starting address is 10, next will be 14, 18, and 1C. So 4 beats will be stored at all these address locations. Okay. So based upon length, it will just keep on incrementing. So in INCR, I'll write over here. In INCR, we have the supported length from 1 to 256. Because my length field is of 8 bit, so it has the, in INCR we have the support from 1 to 256 beats, and for wrap burst we have the support for only 2, 4, 8, and 16. That is the only possible number of beats in wrapping burst, because we have to wrap the address with, if we have the like odd number of beats or more than that, हमारा wrapping boundary, we cannot able to calculate the wrapping boundary. A wrapping boundary, what is wrapping boundary? Like over here we have example of wrap burst. Like our starting address is 04. Okay, so according to incremental, what are the addresses? 48C and 10, because it is incrementing. But in case of wrapping, we'll calculate the wrap boundary and the next address will be the 00. It will wrap the address to 00 location. Okay, so to calculate the correct wrap boundary, we can only have 2, 4, 8, and 16 burst length.
नॉर्मल इंक्रीमेंटल बर्स्ट है तो उसमें हमारे लेंथ पॉसिबल होती है 256 से
इंक्रीमेंटल, हाँ,
और हमारा जो मैक्सिमम साइज पॉसिबल है 128 होता है तो हम एक बार में मतलब अगर पूछे मैक्सिमम तो इतना हो सकता है ना 250 to 128
बट इट इज क्रॉसिंग योर 4K बाउंड्री.
तो 4K बाउंड्री तो है बट मैक्सिमम इतना हो गया था
तुम्हारा फंसा था, तुम्हारा फंसा
मेरा
था,
मेरा
तेरा फंसा था.
तो बट मैक्सिमम इतना पॉसिबल है तो 4K बाउंड्री तो ठीक है
हाँ.
यूज नहीं करते बट इतना पॉसिबल तो है तो अगर
पॉसिबल ही नहीं है ना फिर.
तो अगर मैक्सिमम पूछे तो हम 4K बोल सकते हैं ना
हाँ, मैक्सिमम 4K डेटा जाएगा.
अगर नेट ज्यादा डेटा भेजना है तो वो सेपरेट ट्रांसफर होगा
हाँ,
फिर नेक्स्ट बर्स्ट में एक्चुअली नेट पे मैं देखा था तो उसमें आ रहा था कि 20480 पॉसिबल है तो तभी मुझे लग रहा था कि वो
2048 तो नहीं है, 4096 पॉसिबल है. हेलो सर.
वापस में भी फिर तो 4K बाउंड्री का ख्याल रखना पड़ेगा तो फिर वो 4K ऐसा भी हो सकता है कि वो 4K के जस्ट पहले रैप होगा
हाँ, जस्ट लास्ट में आके वहाँ पे रैप हो जाएगा 4K. अगर सिंगल ट्रांजेक्शन में हमारा 4K का ही है पूरा और लास्ट में लाइक 3K से हमने स्टार्टिंग एड्रेस आ रहा है तो वो 4K पे जाके फिर वो 00 पे चला जाएगा.
बीट बाइट और रैप
बीट और बर्स्ट.
बीट बाइट और बर्स्ट के बीच डिफरेंस क्या है
बीट इज कि जो हमारा एक डेटा जा रहा है, ठीक है, लेट्स से हमारी लेंथ थी 4 बीट्स, तो दैट मीन्स कि एक बीट ऑफ डेटा के अंदर हमारा लाइक बेस्ड अपॉन साइज उतने नंबर ऑफ बाइट ट्रांसफर होंगे. ठीक है, तो वो हमारी एक बीट है.
LENTH जो है लेंथ जो है वो कैसे कर रहा है
लेंथ इज नंबर ऑफ बीट्स.
नंबर ऑफ बीट्स
हाँ,
एक बीट में मल्टीपल बाइट्स हो सकते हैं
एक बीट में मल्टीपल बाइट्स हो सकते हैं.
मैक्स कितने बाइट्स होते हैं
128 बाइट्स.
128 बाइट्स हो सकते हैं
क्योंकि साइज हमारा 3 बिट का है.
बर्स्ट क्या कर रहा है फिर
Burst tell us about कि what type of burst, fixed, wrap और incremental. It will tell कि हमारा एड्रेस कैसे स्टोर होगा. फिक्स्ड के अंदर लेट्स से हमारा इन फिक्स्ड वी हैव द सेम एड्रेस फॉर ऑल द डेटा बीट्स. फीफो वाला एक एग्जांपल हो गया. इन इंक्रीमेंटल हमारे सारे एड्रेसेस इन इंक्रीमेंट ही होंगे. इट विल नॉट रैप अराउंड. और रैप के केस में हमारा बेस्ड अपॉन द अपर एंड लोअर एड्रेस बाउंड्री इट विल रैप द एड्रेस. ये सब में डिफरेंस.
तुषार,
हाँ सर.
यार एक बार ना रैप बाउंड्री कैसे कैलकुलेट होती है वो बता दे इन लोगों को. मेरे ख्याल से ना वो पता नहीं होगा.
नेक्स्ट वीक
ठीक है, ओके.
So like by default we have a formula in the specification. Okay, so to calculate the upper and the lower address boundary. तो यहाँ पे ये सारे फॉर्मूले दे रखे हैं. So you can calculate through this, but like how shortcut, because like हमको थोड़ा we have to be quick to calculate the address boundary. So there is some kind of like we have to create the memory segment. So how the wrap boundary is basically happening. तो यहाँ पे मैंने एक छोटा सा एग्जांपल बना रखा है. Let's say my length value is in wrap we have only 4 possible length, 2, 4, 8 and 16. Okay, so let's say I have taken the size of 4 bytes only in all the cases. So my addresses will be like 048C, 1014, 180. So based upon the length we have to create one segment. Okay, so अगर मेरी length 2 है, so my upper 2 address will corresponding to one address boundary. Next 2 addresses will correspond to next address boundary. So मेरा for according to length 2, my 00 and 04 will be my lower and upper address boundary. Only 2 address location are there. Now let's say my starting address is 00. So this is how my data is going to store. First bit at 00, next bit at D2 as 04. But now let's say my starting address is 04. So first bit is storing at 04. Now my address boundary get hit and it will wrap to the 00 address location, lower address. Okay. Same case for length 4. Now my upper 4 addresses will correspond to one address boundary. Next 4 address correspond to next address boundary. So I have taken an example over here. Like if my starting address 00 is the default case, it is same. It's not necessary. If my starting address is 4, so my last bit is getting wrapped over here 00. Starting address is 8, then it will wrap to D1, D2, and D3 and D4. If 0C is the starting address, then D1, D2, D3, and D4. That's how my data is going to store. Now for length 8, starting 8 addresses will be my first wrap boundary. Next 8 address, next wrap boundary. According to 16, हमारा first 16 addresses होंगे. So ऐसे हम थोड़ा like easily memory segments we have to create, but that is also based upon the length, based upon the size also we have to take care.
It can only be aligned address or not aligned address.
It in case of wrap only the aligned addresses are possible. It's a must mention. Okay, इस पे एक हम like can we do one question like just to be more clear कुछ question होगा.
Both the wrap is incremental and the first address is 01.
My burst is 01. Okay.
Yes, and it needs to be incremented. Suppose the length is 3. So how are you going to store the data? 1, 2, 3, and 4, and the next length from 5?
No. Like in that case, that we call as the partial transfer or partial transfers. Okay. Whenever we are getting a unaligned address, in that case, we have to take care the like the data with my beats with the help of strobe. Okay. In case the unaligned address is generated, every time only the first beat can be unaligned, but the next beat must be aligned. Okay. So like if we are starting with the 01, next address must be 04 only. But for the first beat, we are setting the scope value 0 for the 00 address and 111 for the remaining 3 bytes. ठीक है.
For every transaction, there must be a wrap value,
Wrap value,
fixed or incremental or.
bus type we have to mention every time.
I need to have only one transactions,
One byte of one length. Okay.
and it starts from 02 address. Length is 4.
4 is your size.
Length.
So like you're saying length is my 4 beats you are sending and only one transaction.
No, I mean to say I want to transfer only 4 bytes.
4 bytes.
That means 1 beat.
Yes.
For that, the length would be 4.
0. 0 means 1 beat.
0 means 1 beat. And AW size will tell how many bytes.
How many bytes in a particular beat.
Okay, so I want to transfer 4 bytes. That means I have to fix AW size to 2.
2.
Okay, and then address, I give the address, start address is 02. So what will happen?
From 0 to that increment or a wrapping bus?
Increment.
So is it increment? It will store in 0 to 0.
02 and 03 only? Will
2, 3, 4, 5. No. But it will be a unaligned address. So it will be like 0011. So in that case, like this is the question he's asking. So we can either like decrease the size value. We can send 2 bytes in a single beat and increase the length. So in that case, it will be our aligned address. Otherwise, we have to increase the length value to 1, and after that, in the second length, we can give the scope value 11 and 00. Okay. These two possible things are there. तो इनको भी ये क्वेश्चन करवाई देते हैं कि यू हैव लेट्स से वी हैव टू, हाँ, my starting address is let's say 0 cross 02, okay, and I have to store 4 bytes of data using INCR burst. So what should be the value of my size and AW length? Okay, and before that मैं थोड़ा scope के बारे में, if everyone is not clear, scope will tell us about the active byte lane. Like in a particular beat, let's say over here we have the data width of let's say 31 down to 0. We can store 4 bytes of data. So for every byte we have 1 bit of scope. Okay. So, and it will tell us which data is valid, which data is not valid. So this is one question. Like my starting address is 02 and I want to store 4 byte of data in a INCR burst. So what should be the length and size value? Size will be 2.
Length will be 0.
Length will be 0. Okay.
Stroke क्या होगा?
But is it a aligned address or an unaligned address?
Unaligned.
So how we store a unaligned address?
With strobe.
Based upon strobe. So what should be the strobe value then?
2C is 32 byte
My
32 bit width, right, of memory.
W data width is also 31 down to 0.
Stroke हमारा उस केस में 0 0 1 1 होगा unaligned के लिए. तो हम उसको 1 1 1 1 करते हैं.
1 1 0 0 होगा.
4 byte है ना.
साइज नहीं कर सकते इसमें वो लाइन मिलेगा
Size
हो जाएगा फिर length ये हम लोग length.
So now we have two possible solution over here. Like one thing is we can have the size 2 and my length should be 1. Because according to size 2, this address 02 is unaligned address. Okay, so how my D1 and D2 beat will going to show based upon that my strobe value will be like binary 1100 and
0011.
0011. That's how we can store the 2 beats. Other thing we can do, we can make it as a aligned address. So we can just decrease the size to 1, that means 2 bytes, and my length will be also 1. So I can simply store the D1 and D2 with 1 1 and 1 1 stroke. ठीक है? Any doubt on this question or how the data is getting stored?
So you are transferring the data in 2 cycles.
In 2 cycles.
And on each cycle you will have a scope and the AW length and all the things will be there. But the data will change.
AW length and size is on the address channel, so that is sent only once. Priority का कुछ नहीं है, it's depend upon master.
तुषार सर,
हाँ,
How you are deciding the strobe like bit 1100 and like this is the 4-bit value, no?
This is a
This
4
can be anything or मतलब, I'm not
नहीं नहीं
understand.
नहीं so if we see like my starting address is 02 correct and my data
Yes.
width is like 31 down to 0 I have one yes यहाँ पे है so basically let's say my starting address is 10 मैं just scope के लिए example दिखा रहा हूँ this is my 8 byte of bus width my W data width is 63 down to 0 and my size value over here is 2 that means 4 byte so this is we call as a narrow transaction like on a wider bus width we want to store less number of byte we want to we have a less number of valid data byte so in that case now over here my starting address is 0 cross 14 this is a align address so my like in the first beat whatever the d1 we are sending in first beat this will be my the addresses that we are accessing to so but my starting address is 14 so 14 15 16 17 for all these 4 byte we are setting the strobe high and from 10 to 13 we are setting the strobe as low सो वी हैव टू कैलकुलेट कि कौन से एड्रेसेस पे हमको डेटा स्टोर करवाना है अब जो हमारा नेक्स्ट D2 बीट होगी इट है द स्टार्टिंग एड्रेस फ्रॉम 18 टू 1F करेक्ट अब हमारा साइज 2 है तो हमारा जो स्टार्टिंग के 4 बाइट्स हैं दैट इज वैलिड इसके लिए स्ट्रोब इज हाई एंड फॉर नेक्स्ट 4 बाइट माय स्ट्रोब इज लो now my pointer is at 1C location now at the D3 data beat I'm setting the scope as 11110000 F0. Okay. मतलब we have to calculate the addresses in for the scope as well. So जो हमने वहाँ पे example लिया था D1 D2 हाँ. So according to 10 my addresses will be like 00 01 02 and 03 these are the addresses ना so हम अभी यहाँ पे 02 और 03 के लिए स्ट्रोब को हाई कर रहे हैं और बाकी 00 और 01 एड्रेस के लिए हमने स्ट्रोब को लो कर दिया बिकॉज आवर स्टार्टिंग एड्रेस इज 02 फॉर द नेक्स्ट बीट वी हैव 04 05 06 07 these are my addresses so for next beat we are sending the strobe high for 04 and 05 only ठीक है 6 और 7 के लिए हमारा स्ट्रोब वैल्यू इज 00
Tushar sir,
हाँ
so if you're providing the starting address and the burst type is increment, so why do we just need the strobe?
why we need strobe for because in case see, there are two things one is the unaligned address
नहीं इवन वो
Why?
अनलाइन होगा भी तो रिसीवर
हाँ.
का स्टार्टिंग एड्रेस है और उसका साइज है वो तो यूजर से नहीं कैलकुलेट कर सकता वो डायरेक्टली यहाँ से स्टार्टिंग एड्रेस है ये उसका बीट साइज है और ऐसे डेटा आता रहेगा हमारे पास लाइक
one thing is like for every beat of transaction only the first beat can be unaligned but the next beat must be aligned okay so उसका aligned और unaligned को difference create करने के लिए there might be possibility कि हमारा now let's take one example let's say my starting address is C7 okay and my byte my size value is 8 bytes okay that means 3 my size is 3 so this is my unaligned address correct so I have to tell like only my last byte is active so we have to calculate with we have to tell it with the help of strobe value and my next address is all the addresses aligned we have to tell it with the help of the strobe value and other thing there might be possibility that it's not necessary whatever the width of data, that all widths we are accessing for every burst. There might be possibility we are accessing the narrow burst performing the narrow transactions, and it is must, like in all the scenarios, we by default the W data is maximum 512 in most of cases. So it's not necessary every time we are sending the 512 bits of data. So to tell about the uh, like the narrow transaction, the strobe value is required. Until unless we are not providing, we don't get to know like what is the next address pointer. Because of these, only these two reasons. One is for first beat, it will be your, it is aligned or unaligned. For second beat is if it's a narrow transaction. Doubt, doubt. क्वेश्चंस करेंगे इसके बाद सीधा बस.
What are the possible data bits? I want to bit 64 bit, 32 bits.
51 अब न्यू आईपीज में 1024 भी आ जाता है. हाँ
128
नहीं.
Let's check out 32.
हाँ हाँ
Possible है 16 and 8.
क्योंकि हमारा एक बाइट मतलब साइज पॉसिबल है ना.
In this case of aligned addresses, the address is D1 aligned or
नहीं, 4 byte align it's not necessary. It should be aligned based upon the size. जो हम यहाँ पे size provide कर रहे हैं AW size में, उस पे aligned होना चाहिए हमारा. Now let's say my size is 3, so 8 byte we are accessing. So from 1 to 7, all those are unaligned addresses. If my size is increasing, so in between all those are unaligned addresses.
दूसरा एक क्वेश्चन था.
हाँ.
जिसमें राइट ट्रांजैक्शन है.
हाँ.
बस्ट इज रेप, साइज इज 1, लेंथ इज 3, and address is हाँ हाँ हाँ. Wrapping burst है, size equal to 1, length equal to 3, and address is 11B4.
11D4.
B for banana. 11B4. और बस साइज है 32. तो इसमें अभी हमें we have to found strobe for the 4 transaction, 4 bit.
So बताओ like my size 1 means 2 bytes of data. 3 means 4
bits.
So I am sending D1, D2, D3 and D4.
D4.
Correct.
Addresses will be B4, B6, B8 and B.
Address will be B4, B6, B8 and B8. Okay.
And 11B4 is aligned address.
11B4 is aligned address, yes.
So
what should be the strobe value?
Yeah, 3C, right? For transaction.
क्या दोबारा बोलना? CC
3 for first transaction it should be 3. And for second one it's C. And again 3 and C. Is it correct?
हम बाकी सब बताएंगे. Everyone has seen now. कुछ इशू है इसमें? नहीं, हाँ रैप ट्रांसफर.
अगर साइज आपका 2 bytes है, then your aligned address are also in the difference of 2 bytes.
2 bytes.
So all the scope should be 3 only.
All the scope should be 3 only. But it's the W data width is 31 down to 0. It's also a narrow transaction.
So will be 8 bit, 4 bit.
4 bit. ये hexadecimal में बोला है 3C. Everyone is calculating.
This is first.
Yes. This is a wrapping first.
So the thread should be B4, B6, B0, and B2.
You're saying B4, B6, B0, and B2. Okay.
Yes. Yes.
And what should be the slope then?
I got the same width with mine.
The same stroke with the.
Oh, this same. Okay. अक्षय कोई मतलब ये होगा एड्रेसेस
B4, B6, B8, BA ही होना चाहिए.
ऐसा क्यों?
सर 2 बाइट का डेटा है तो
लाइक हमारे एड्रेस क्या होंगे 0 क्रॉस 0 0 0 क्रॉस 0 2 4 6 8 BC 0 क्रॉस 1 0 ये हमारे एड्रेसेस होंगे ना. So based upon my length of 4 1 1 1 1, this will be my first wrap boundary.
Yes.
So now my starting address is B4, D1, D2, D3, and D4.
Okay.
ठीक है ना?
Okay.
And slope values are correct because हमारा data width is 31 down to 0. So in first we are accessing 4 and 6, so it will be 3. It will be C, 3 and C. So interviewer is also asking the question like this way only, but तुम्हारा तो अब अलग है. मतलब आपका तो अलग है, जो इनके वाले होंगे ना, नहीं इनके भी नहीं, इनके वाले होंगे, उसमें तो ऐसे ही क्वेश्चन पूछ रहे हो. Stroke calculation, like हमारा starting address है 04 5 6. ये हमारा फर्स्ट एड्रेस लाइन होगी. For the first beat we are sending slope 1 1 0 0. For the next beat we are sending slope 1 1 0 0. It will be 3. It will be C. क्या डाउट है जया? हो गया ना, सही बताया ना? ठीक है। एड्रेस 2 से ही स्टार्ट करा है हमने। ओके 4 से करा है। हाँ 2 से स्टार्ट होता तो यहाँ D1 D2 D3 D4 आता, स्ट्रोक भी डिफरेंट आते, C3 C3 आता। हाँ 0 0 0 1 एड्रेस होता, 0 2 होता, तो पहले इन दोनों का स्ट्रोक हाई होता C, फिर ये वाला होता, फिर ये होता, फिर वापस C3 C3। और ये 0 से स्टार्ट होने में तो बेसिक आप कैलकुलेट कर लो, उसमें तो रैपिंग का कुछ है ही नहीं।
सर एक बार अलाइंड और नॉट वो बता देंगे क्या?
ठीक है, सो हमारा with this example only we'll see what is aligned address and unaligned address. So now this my size value is 2 bytes. Okay, so in one beat we are sending 2 bytes of data. Okay, so our address will be like 02486. So whenever my addresses are coming in multiple of my size, what is unaligned and aligned address?
मतलब डिपेंडिंग अपॉन जो नंबर ऑफ बाइट्स होती है, जैसे अगर 2 बाइट्स हो तो हमारा अलाइंड एड्रेस 0 2 4 6 ऐसा कर देगा,
Multiple of my size.
हाँ,
So that will be our aligned address. And apart from that, अगर हमारा 01 address आता है, so that or 03 05, it is not a multiple of my size, so that will be our unaligned address. ठीक है?
ओके
अभी क्वेश्चन ट्राई करते हैं। लेट्स से माय स्टार्टिंग एड्रेस इज B5 and my size value is 3 and my length is let's say 8. So इसके अकॉर्डिंग हमारी स्ट्रोक वैल्यूज क्या होंगी? And my W data width is 3 है ना? 3 का मतलब 8 by 8 128 127 down to 0. INCR burst. Eight beats. This is length is 7 and 8 beat. हाँ.
FFE0 होगा।
क्या क्या?
FFE0
FFE0
E0
5. बट एक सेकंड, मैंने क्वेश्चन में कुछ इशू बताया यार। My size is also Akshay. Size is 3. Maximum 8. हाँ.
तो वो होगा कि 1FE होगा, 1FE0 for D1. No, D1.
अच्छा, D1 is
1FE0. तो हाँ, ये 8 बाइट्स हो गई ना एक ट्रांजेक्शन।
अगर अच्छा, बट इसके अकॉर्डिंग हमारा D2 भी अनअलाइंड हो जाएगा ना। B5 हाँ।
I have the answer that the first one is 00E0. Zero E0. The next one is FF00. 00FF.
Yeah, all that.
And so on. Yeah.
पहले वाले में से डबल जीरो डी होना चाहिए।
डी B567 लास्ट के 3 बिट ही है, ये होता है। ये जो मार्क है डबल एफ 0 to 8 कवर हो गया ना। अब 8 to 16 नेक्स्ट वाला सेट आ गया, तो FF00 हो गया। मतलब जो फर्स्ट एड्रेस लाइन है यहाँ पे हमारा B0 से BF तक आ रहा है, 128 बिट है लेंथ, मतलब 16 बाइट्स हो गया। तो B0 से BF, फिर C0 से CF फर्स्ट डेटा में, तो B5 से स्टार्ट कर रहे हैं और अब हमारा साइज 8 बाइट है, तो B0 से B8 वाला हम एक बार में एक्सेस कर रहे हैं, तो उसके अकॉर्डिंग E0। अब नेक्स्ट में जाएंगे तो B8 से BF उसका हाई हो गया 111, नैरो ट्रांजैक्शन भी हो गया, अनअलाइन भी हो गया। EF E0 1F E0 तुम भी यही आंसर दोगे कैसे?
हमारा स्टार्टिंग एड्रेस B5 से 8 बाइट राइट, तो फिर
तो नेक्स्ट एड्रेस अलाइंड रहेगा तुम्हारा।
B5 से फिर राइट,
नेक्स्ट बीट शुड आल्सो बी अलाइंड। हमेशा सिर्फ फर्स्ट बीट अनअलाइंड रह सकती है, नेक्स्ट बीट हमेशा अलाइंड होगी। स्ट्रोक का मतलब ही क्या है हमारा, और अब फर्स्ट बीट में जो एक्सेस कर रहे हो दैट इज ओनली फ्रॉम B0 to B7।
B7 से फिर 1 होना शुरू होगा अलाइन करने के लिए,
बाकी B5 से B7 कहाँ गए? 5 yeah B5 6 7 8 until 15 C0 C1 C7 C8 मैंने like I have taken this pass way. So in first beat we are accessing only this much of address, this much of addresses, because my size is 3, so 8 bytes we are accessing and my address is unaligned. So it is starting from B5. Okay, B5 6 7 only 3 bits can be high. Okay, 1 1 1. So what would be my stroke? 0 0 E0. Now my pointer goes to 8 B8. In the next beat I am accessing B8 to B15, that is FF 0 0. This will be my D2 beat. For this it will be FF 0 0. Again pointer is to C0 location. So it will be now basic narrow transaction. FF 0 0 0 0 FF. Only the first beat stroke we have to take care. Clear हुआ ये how the D1 D2 D3 beats we are sending.
So basically, it depends on size and right data width, right?
Yes.
Mm-hmm.
The data will tell you like the complete address line we are accessing. Based upon that, based upon the size, we are seeing what is the aligned or unaligned address, and after that we are just checking for the scope, how much, based upon the size, how much data we are accessing. सारे बस ये 3-4 पैरामीटर्स हैं जो हम 1 2 3 4 5 सारे पैरामीटर टेक केयर करके we have to check the stroke value. Now according to this, if let's say my starting address is B8, इसमें किसी को डाउट है अभी भी स्ट्रोक में?
नहीं.
Anyone else? शुभम, हरिओम.
हाँ सर समझ में आ गई, ये स्ट्रोक समझ में आ गया.
वियतनाम टीम. ठीक है. Now let's say my address changed to B8 and my wrap, it will be my wrapping burst. So what should be my upper and the lower wrap boundary? हमारे D1 D2 wrapping addresses क्या होंगे? My starting address is B8.
previous question था B4 वाला, जो था starting address B4 था,
हमने ऐसे ही किया था. B5. हाँ.
B4 और B5.
नहीं, B5 स्टार्टिंग एड्रेस हमने लिया था ना.
B4 था ना सर, जो
वो ऊपर वाला ही अलग है यार, ये वाला.
स्ट्रोक कैलकुलेट कर रहा हूँ C3.
हाँ.
तो स्टार्टिंग एड्रेस स्ट्रोक कैसे स्टार्ट से अगर स्ट्रोक या 0 0 0 0
हाँ. आपका एक
ओके ओके सर, वो 0 से 0 के तक वो पूरे शो चली जाएगी ना, जीरो वोल्ट से
आपका जो W डेटा बिट के अकॉर्डिंग 0 से 4 एक्सेस कर रहे थे ना, नेक्स्ट एड्रेस 4 से आएगा, उसके नेक्स्ट एड्रेस 8 से आएगा।
Address should be B8, B0, B8, B0 like this.
B8 B0
B8
हाँ
again B0.
B0 then
Again B8.
then
हाँ B0 B8 B0 B8.
but why my address is like इसका बेनिफिट क्या हुआ? रैपिंग बस है कहीं ना कहीं नहीं है।
Sir, it will be B8 80 88 90.
आपके अकॉर्डिंग C0 एक मिनट यश भाई
B0 B8 0 E8 then again B0 0 E8 then B0
Yashpal, what you saying?
Sir, B8 80
80
88 98 sorry 88 के बाद सर 90.
sorry
90 98 A0 8 B0 B0.
Sizes 8 length is also 8.
The second one is correct, I guess. B8, C0, C8, D0, D8, E0, E8, and B0.
1, 2, this one.
The first one, I think the first one is the correct answer.
First one.
I chose the first one, sir. I have the same answer.
Okay. आठ लेंथ है और एक में 8 बाइट आ रही है, सो स्टार्टिंग एड्रेस 00 भी लेंगे, नेक्स्ट एड्रेस 40 आएगा, है ना, 048 C। तो हमारा जो B8 आ रहा है वो 80 से C के बीच में आ रहा है ना। आप डिस्कशन कर लो अब ये वाला। हाँ B8
तो पहला वाला सही लग
रहा है या कंफर्म है? क्या लॉजिक क्या है
सर? मतलब सही सर, ये रैपिंग इसमें होगी ना, तो जैसे ये तो C0 जा रहा है, तो सर ये बाउंड्री उसकी बदल जा रही है ना, हमको उसकी बाउंड्री में रखने के लिए ऊपर मतलब B8 के बाद 80, ये वाले जो ये दूसरा वाला इसमें सर बाउंड्री बदल जा रही है ना, C के बाद C8 फिर D जा रहा है।
हाँ। So अब like my length is 8 and size is also 8 byte. So जो हमारा like if we see the boundary, अगर if we starting from 00 then 08 10 18 till 0 from 00 to 38.
38.
That will be our first address boundary. Then from 40 second, and from 80, and then C0.
Yes.
Like this, our address boundaries are created. So this, what is the address? B8 is lying within 80 address boundary. So that's why B8 is our last address. Then it is wrapping to the first address 80889098 A and B.
सर FF00 D1 का होगा FF00
FF00 इसका
and then 00
this is stroke she's telling. FF00 and stroke चलता रहता है. ठीक है. Along with that, we also have to tell about the slope. So B8 is the next half of the data width. So the slope will be like FF00. After that, 00FF. Yeah. Address calculation.
सर और अगर यहाँ बाउंड्री कुछ रहेगी तो दैट विल बी F0 बोलेंगे ना नेक्स्ट.
नहीं तो आप 38 भी बता सकते हो. 38 will be last address, then we'll wrap to 00 address. हाँ मतलब इस केस में B8. ठीक है. अभी इस पे और क्वेश्चंस करते हैं. मीनवाइल विल कवर अदर टॉपिक्स. लेट्स से ठीक है. मतलब इसमें कुछ डाउट है? व्हाट इज अलाइन एड्रेस, अनअलाइन एड्रेस, हाउ द नैरो ट्रांजैक्शंस आर वर्किंग, मेजरली these three, and what is wrapping bus. इन तीनों पे हमारा सबसे ज्यादा क्वेश्चंस होते हैं. तो एक बार इन पे और क्वेश्चंस कर लेंगे, बट वी आल्सो नीड टू कवर अदर टॉपिक्स. नैरो इट्स जो अभी ये हमारा था, वाइडर विड्थ और साइज कम. डेटा बस विड्थ हमारी बड़ी है, उस पे हम एक्सेस सिर्फ कम बाइट, छोटी बाइट कर 4 बिट की डेटा बस, 4 बाइट की बस है और 2 बाइट एक्सेस कर रहे हैं. तो हम स्कोप से खेल रहे हैं. तुमने कहा अभी स्कोप समझ आ गया. नहीं मेरे को ये नहीं. ठीक है. सो राइट में तो कुछ इशू नहीं है. राइट ट्रांजैक्शंस क्लियर है. रीड में बेसिक ये है हमारा, सिर्फ एवरीथिंग रिमेन्स द सेम, बट इन रीड वी आल्सो हैव द रीड रिस्पांस along with the read data. Okay, in this also there is one last W last signal is also here. Yeah. नहीं निकली उसकी. क्या डाउट है? यहाँ पे सेम वही वाला क्वेश्चन ना. B8 है ना. सो हमारे लेंथ कितनी थी? 8. साइज है 8. अगर 00 स्टार्टिंग एड्रेस है, कहाँ तक एड्रेसेस जाएंगे अकॉर्डिंग टू 8 लेंथ? 38 तक. 1 2 3 4 5 6 7 8. नेक्स्ट एड्रेस क्या होगा? 40. उसका नेक्स्ट एड्रेस 80. और ये B8 किस उसके बाद आता है C0. तो B8 कहाँ लाया कर रहा है? 80 से C0 के बीच में, है ना. अब अगर हमारा B8 स्टार्टिंग एड्रेस है, नेक्स्ट एड्रेस क्या होगा इसका? +8 कर रहे हैं तो C0 पे, बट हमारा एड्रेस बाउंड्री नेक्स्ट स्टार्ट हो गई. तो वो वापस रैप करके 80 पे हमने B8 के बाद नेक्स्ट एड्रेस विल बी और 80 इस एड्रेस बाउंड्री के अंदर लाया करेगा. FF0000FF. B8 will be your next half ना. So we have this W last signal which tell us about the last beat being transmitted. So जो भी हमारा like whatever the last beat of data we are transmitting on write data channel, at that time we are going to assert the W last signal, because like in AXI4 as we don't have the AWID, so हमारा जो data जा रहा है we have to like will be aware this is my last beat and after that next data is going to start. ठीक है. Same in read channel we have R last which tell us about the last data beat. Now in read data channel and response channel we have the response for every beat of transaction. In AXI we have the response for the complete burst, but in read we have the response for every beat of transaction. For every address being incremented we are getting the response signal. Okay. It is basically like in case our address boundary getting crossed or we are accessing some kind of reserved location or a read only location, at that time maybe the slave can respond with a slave error. So this is about the all the 5 channels. Okay, there is one more case. I have not told you about the ready valid in between the channels, dependency in between the channels. एक छोटे से टॉपिक में हाँ. This is the handshaking for the read address and read data channel. Like we have address and valid. So my R valid can only assert whenever the AR valid and AR ready both are asserted. So in whenever the address read address channel is completely sampled, at that time only the R valid can assert. Okay. Now we are coming to AXI4 diagram. So this W valid don't have any such dependency on AW valid and AR ready. But B valid has the dependency on all the 4 signals. So that means the response should generate only when the address and data both has been driven. But data can arrive before the address in case of AXI 4 and 3 as well. Okay, so it might be possible the master has generated the data on the write data channel, and after that it has generated the write address corresponding to that data. But now we don't have the ID field in data channel. How it will correspond to the address? It will be basically in order. जिसके लिए भी data आ गया वो उसका buffer में रहेगा. Whenever the address is coming, it will corresponding to that first data. ठीक है? Now we have 4 different type of responses: OK, XOK, slave error, and decode error. OK is whenever a normal transaction is getting successful, we are getting a OK response. Then we have a exclusive transfer in AXI. So whenever a exclusive transfer gets success, we are getting a XOK, and a failure. So it's a different type of transaction वो भी करेंगे. ठीक है. ये अभी तक like till now we have covered a normal access transaction. And a failure of a exclusive transaction will get a OK response. Slave error in case of any issues on the slave side, like accessing wrong location or some kind of FIFO overrun, underrun, any issues on the slave side cause the slave error. And decode error is handled by the NOC. Like in case we are incorrectly accessing the address range, the address is not lying within the range of the slave. So that will be a decode error, and it
What
will
is the
be.
range of addresses? Like,
वो तो it depends upon the IP. वो like आपका SOC architecture पे depend.
there can be multiple slaves and multiple masters.
हाँ.
All these are communicated by interconnect.
By interconnect only.
हमारे पास एक एड्रेस नहीं है, आउट ऑफ बाउंड्री एड्रेस हम
हाँ.
मास्टर उस पे राइट कर रहा तो वो स्लेव एरर है डिकोड एरर.
Decode error. Like if the address we are providing that is not lying within any particular slave range, so it will be a decode error. How the interconnect going to handle that error, that particular address? उसको पता ही नहीं उसको कहाँ route करना. तो उस पे डिकोडर है। तो और क्या टॉपिक है?
सेम आईडी को इसमें क्या बोल रहा था?
हाँ,
सेम आईडी आ रही है इसमें क्या होगा?
same ID in case our AWID और ARID is same. Like अगर हमारे यहाँ पे 111 आ रहा है, so all the things my read data channel, write data channel and write response channel, ये सब in order ही work करेंगे। जिस order में transaction सही है उसी order के अंदर data और response भी आएगा। ठीक है, तो इसी में हमारा टॉपिक आ जाता है आउट ऑफ ऑर्डर रिस्पॉन्स का, कि अगर हमारे पास डिफरेंट आईडीज हैं 1 2 3 1 2 4, तो यहाँ पे जो रिस्पॉन्स है इट कैन बी इन डिफरेंट ऑर्डर, आउट ऑफ ऑर्डर, दैट इज आवर आउट ऑफ ऑर्डर रिस्पॉन्स। एंड इन केस वी हैव द WID in AXI3, we have like AXI3, so in that case we have a concept of write data interleaving. In that case we are mixing up the data of multiple IDs, like we are sending 2 bits of ID1, then we are sending 2 bits of ID2, then again we are sending the 2 bits of ID1. So basically we are interleaving the data of multiple transactions. Any doubts on this thing?
हमारे पास मल्टीपल बिट्स हम लोग सेम आईडी पे भेज रहे हैं, जैसे 2 बिट्स हमने सेम आईडी पे भेजे, दूसरा बर्स्ट हमने सेम आईडी पे दोबारा भेज दिया।
नहीं, राइट डेटा इंटरलीविंग कर रहे हो ना आप? किस में डाउट है? इंटरलीविंग में ना? हाँ, सो इट विल बी लाइक, ये शीट अच्छी बन गई, इसको सेव रखेंगे। नहीं, सारे एग्जाम्पल हो जा रहे हैं इससे। This is write data interleaving. We have generated 2 transaction, ID1, ID2. ID should be different in case of interleaving. That's only then we can perform a write data interleaving. Now my first ID data has started, D1, D2, 2 bits has been completed. Now I have started sending the D1 and D2 for the second address. ठीक है, now again I'm sending the remaining 2 bits of the first address. Now after that D3 and D4 for the second. So the data is interleaved, we are mixing up the data. अब इसका benefit क्या है हमारा? Why we perform write data interleaving? Like if the 2 different master or like it basically write data interleaving happens on the slave side. If we have the interconnect, slave side में ही हमारा interleaving का main benefit है, because 2 different masters, both of them are working on the different frequency. तो एक में भी high frequency पे काम कर रहा है, दूसरा बहुत low frequency पे काम कर रहा है, and both of them are accessing the same slave. तो इन दैट केस स्लो वाले का भी ट्रांजैक्शन चल रहा है, बट मीनवाइल वो हाई बैंडविड्थ वाले को डेटा भेजे जा रहा है, उसको कहीं स्टक होने की जरूरत नहीं है। ये मतलब मैक्सिमम जो मैंने वर्क करा है 1 गीगाहर्ट्ज पे करा है, ठीक है, और ये भी क्योंकि सॉफ्ट आर्किटेक्चर पे डिपेंड होता है सारा, वो डिजाइनर से इसको डिसाइड करते हैं, क्योंकि मेजर
कोई
रिस्ट्रिक्शन नहीं है, क्योंकि जो मेजर आपका आईपीस जिस फ्रीक्वेंसी पे काम कर रहे हैं उसके अकॉर्डिंग ये एक साइड की फ्रीक्वेंसी भी मतलब चेंज कर लेते हैं, मतलब 500 600 मेगाहर्ट्ज या 1 गीगाहर्ट्ज वो आईपी पे भी डिपेंड कर जाता है। जैसे जो पीसीआई सब सिस्टम था उस पे 1 गीगाहर्ट्ज था, हमारा डिकोडर वीडियो एनकोडर डिकोडर सब सिस्टम था उस पे 1.2 गीगाहर्ट्ज भी था, और कहीं पे 800 मेगाहर्ट्ज भी था, डिफरेंट हर एक पे रहता है।
हमारा वो 9 कोर स्लेव का इंटरफेस जो है वो इंटरलीविंग सपोर्ट कर रहा है
हाँ
और ऊपर वाला नहीं कर रहा था
हाँ
तब भी नॉक इंटरलीव कर दो तो सेपरेट
हाँ
इंटरलीव
now has to take care for those conditions. ठीक है, ये I think it's all the major topic and how the narrow transaction, aligned, unaligned, burst type. Any doubt so far, because we are only left with the exclusive transactions. Apart from that, everything is I think covered.
प्रोटेंशियल बात है ना क्या
Protection, yeah, broad signal, I'll tell you. We have a broad signal and a cache signal. So cache में मैं तो अभी नहीं घुसते हैं क्योंकि उसमें पूरा cache का concept आ जाएगा. What is cacheable, bufferable, modifiable? Majorly, I'll tell you like modifiable, cacheable, bufferable. What's the difference? Cacheable is like we have some kind of cache memory inside the knock or the master. So that it is storing whatever the write or read transaction we are performing. तो वो cache से ही उसको process करके it can return the data or provide the response based upon the cache. Or if we are like generating the two different kind of like two transaction are generated by two different master on the overlapping addresses. So वो further slave को एक single transaction ही provide कर सकता है क्योंकि वो cache में data अपने आप overwrite कर देगा. Okay. And bufferable is nothing, just it is storing as a buffer. The request has been stored as a buffer, it is in a queue, and the same request will go to the slave. Maybe after some time, it is just a buffer, simple buffer. And modifiable is like, let's say we have accessed a huge transaction. Master is supporting a huge bit of 512 bit. But on the slave side, my data width is only 32 bit. Okay, now it has to modify the parameters like the length or the size, it has to modify it. So, or if in that case, we need that modifiable attribute as higher so that the knock can modify the transaction based upon the slave. ये हमारे इन तीनों में basic एक difference है. Apart from that, जो
early भी response
early भी response हो. In prod signal, we have it's a 3-bit. We have privilege, unprivileged, secure, non-secure, data and instruction. So data instruction is simply like what kind of access we are performing. Like let's say we are performing some kind of configurations, like we are updating some kind of configuration update or something like that. So it will be a instruction access, and whenever we are sending the data, it will be a data access. So वो हम यहाँ से distinguish कर रहे हैं. And secure, non-secure, it's just a memory type, the type of memory or type of access we are performing. Like along with data access, we like take care of the secure or the non-secure memory region we are accessing. So now a secure master can access to secure as well as non-secure, but a non-secure master cannot access to a secure region. Basic rules. Same with the privilege. Now in the along with the instruction access, we have to take care about the privilege or the unprivileged access. Like it will tell us about the availability of the resources, because in case of configuration, might be the privilege master has the access to all the resources, but some of the master, maybe a small master is there which is not has the access to all the resource. So that will be a unprivileged access. तो हमारा पूरा जो भी रिसोर्स पूल है उसके अंदर सब कुछ, एक प्रोसेसर को सब कुछ एक्सेसिबल होगा, बट एक और कोई मास्टर होगा उसको सारी फीचर्स एक्सेसिबल नहीं होंगे. तो उस केस में ये वाले हम फंक्शंस को यूज करते हैं. User bit is there, so that is completely user defined. हम if like master has to provide some kind of user data. It is optional or user defined है इसकी width, whatever the width user want to like send, or किस way में इसको use करना है, that is only implementation specific. कि क्या information, what kind of information master want to provide to the slave. ठीक है. And remaining like region QS cache we can just ignore. Lock is of 3 types basically. 00 is like a normal access till now what we have discussed. 01 is exclusive access and 10 is locked access. Lock access is only in AXI3. In AXI4 lock access is also removed, so only 2 types of accesses are there, normal and access in AXI4. Okay. In lock access it is nothing like over here I have like this is our one. Let's say we have 2 master, a knock is there and 2 slaves are connected. Now my M1 want to communicate with S2 and want to send the transaction back to back and don't want to lose the control of the bus. So M1 can generate a locked access to the S2. So it will lock this path. So if the M2 trying to access to the S2, it will not get the permission. Okay, so until a unlocking sequence has been generated by the M1 master. So वो पूरा ट्रैफिक को ब्लॉक कर देगा until वो लॉक नहीं होता. So अब ये ट्रैफिक को ब्लॉक करते हैं, इस कॉम्प्लेक्सिटी की वजह से 1/4 के अंदर ये लॉक एक्सेस हटा दिया था. नॉक कॉम्प्लेक्स ज्यादा हो जाता है इस केस में. Any doubt so far or we can start with या फिर we एक ब्रेक के बाद स्टार्ट कर लें. एक्सक्लूसिव देख लेंगे और कुछ क्वेश्चंस और देख लेंगे. Team, any doubt so far? Hello.
No doubt. No doubt.
No doubt.
Sir.
So I think we can continue then. Okay.
Yeah. Okay, sir.
Okay. Okay. So bye everyone.